Hello, JSConf. I'm super excited to be back here. It's been a few years since I've been at JSConf EU. I wish I could say that accessibility has gotten a lot better in that time, but we still need to be reminded that people with disabilities are left behind quite often. So to tell you about accessibility today, I'm going to do something a little bit different. I don't have any slides. Instead, we're going to take a live debugging tour of a React application that I've built with a few components, the goal of which is to teach you how to debug components for accessibility, because you are all capable of doing it. You just need a little bit of knowledge and a little bit of empathy for your user. You can find this repo with these components on my GitHub. It's Marcy Sutton /empathy-driven-development. And with that, we're just going to dive right into some code. So if we go over to the browser, I can show you this basic component library that I've built. It's got 3 components in it: a login form, a card flip, and a menu. And it's worth reiterating that we can't cover all of it in 25 minutes, but I'm going to show you some keyboard mechanics, some screen reader support, and some things that are chronically forgotten. And it really ends up impacting users. So to get started, let's look at our login form. It has 3 fields in it. Those fields have placeholders. Unfortunately, a placeholder is not enough for a screen reader user to use a web page. And I really wish that we could move on from this, but I see this so often, so let's check out how we can fix this. If I were debugging this on a real page, I would open the developer tools. So if I open up my dev tools in Chrome, I can go and inspect this HTML and see what's going on. A quicker way to do this is to use a tool like the Axe Chrome extension. There are other tools. I like this one. I happen to work on it. It's built with React and JavaScript. I can analyze any web page and see what's going on with this. And sure enough, those placeholder attributes are not enough for a screen reader user in all browsers. So that's something we could fix. There's also an error here about content not being contained in a landmark region. So our main content is just sitting there in the DOM, and it's not wrapped in a landmark. So we're not taking advantage of HTML for screen reader users. So let's go back over to my text editor and start poking around and fix some of this stuff. So in my app.js file, it's written in React. This is where everything comes together, all of my components. I can see that there is a header element here, so that acts as one landmark. But if we scroll down, there is a main div that just has a class name, and guess what? That's not very semantic. So let's go fix that. I'm going to change this div to a main element, which has an implicit role of main. But if you're supporting Internet Explorer 11, which a lot of users with disabilities still rely on, we actually need to bolt on a role. So I'm going to bolt on main. It is a little redundant, but if you're actually supporting IE 11 or below, you need to add that to expose the semantics. Similarly, on the header element, we can add a role of banner, and that will expose the fact that this is a global header, not to be confused with a header inside of an article tag. So that way, assistive technology, they can use these landmarks as navigation points in our application. Much like they might navigate by headings, you can also navigate by landmarks. So we uncovered those first few problems in the Axe Chrome extension. I'm also going to show you the login form, since we looked at that. The login form demo in JavaScript, this example uses an array with the 3 field names. Those fields end up getting passed to our login form, and then we can create a dynamic login form based on this array. So if I go look at the login form component, it takes that array of fields, maps them to a set of inputs. So each input, we iterate over its name. This is where those labels are missing. So I'm going to go here and add a label. And I'm going to use the key from this, the array value to add a name. Now, we've got something a little redundant here with the placeholder. This is sort of a design decision that you might need to make with your design team. Do you have a visible label, or do you use something like ARIA label? I'm actually going to opt for the visible label, because I don't know about you, but when I type in a form field that only has a placeholder and I forget what I'm typing in and I have to back out and go back, so I would really advocate for the visible label. If it was something like a telephone number and it had a specific pattern, then that would be a good case for a placeholder. And additionally, we can use HTML a little bit better here by adding a field set element around our form fields. So I'm going to wrap this in a field set, and then this h2 heading I'm going to wrap in a legend tag. So leveraging HTML's capabilities to make a more semantic and accessible form. No matter how you're delivering your HTML, this happens to be in JSX using React. So to test this, in the spirit of test-driven development, I'm going to apply Selenium WebDriver. I have a script in my package.json file called integration. So I'm going to run npm run integration. It's going to use Mocha, fire up the app in the browser, and it has found that there are no violations in this. If we go look at this test, login, no pressure, doing it live. Login. This is the fun part, right? Watching me type. So I have a test here. It's actually using the Axe WebDriver JS library, which is the same accessibility API we were using in the browser extension, but we can pull this into our integration tests and leverage that accessibility API, so we don't have to know the nitty-gritty details of accessible names and color contrast and a lot of the common accessibility problems. So I'm using Selenium here because that's a lot like what a real user would experience. I can fire up a browser. In this case, I was using Chrome. It goes and hits that localhost URL for the login form. And then I have a single test in here. It uses axebuilder.analyze. And what that will return to me is an object with accessibility violations that I can use to assert accessibility problems. Now, it's also worth pointing out that this will only catch the low-hanging fruit, so those basics that we commonly forget. It's nice to have a tool point out to you that you've forgotten it, and then you can move on to use your human power for more complex problems. But this is a really great way to start. So we fixed our first few problems in our login form. Let's go back to the browser and look at our next component. I guess one thing to point out about this login form, when I added the field set, it did add a border around it, but that's an easy fix to make with CSS. So you can style it however you want, but under the hood, we've added some really great semantics to this form. So on to our next component, the card flip. Now, I'm not going to name where this came from, but it came from a real website, out of respect for the innocent. It's a little profile. So in this case, I'm using a picture of my dog, Mr. Rainier McChetterton, because I can't get enough of his cute face. But when I hover over this, it reveals content on the backside of this card flip. Now, if I'm using a keyboard only, say if I tab through this web page, I don't ever reach this card flip because it just works with the mouse. So for a keyboard-only user, someone with a disability, someone using a screen reader, or even me by the end of the workday or the work week when my programmer elbow really flares up and I can't use a mouse anymore, this is super unusable. So it needs something to make it focusable, and we need to be able to flip it back and forth. I'm actually going to make a design decision here to make this work on click instead of on hover. Because I can tell you from experience that the reality of maintaining hover animations and keyboard support, like you probably don't want to make this move on keyboard focus, so that one-to-one interaction is not the same anymore. So I'm going to make a judgment call here and change it to work a little bit differently. And just to give you a little more info, before we go and make our changes to this, we can go inspect what this markup under the hood is looking like. It's a series of divs. It does have an image for the picture of Rainier. I've got some content. The backside of this card, we want to make it revealed when we interact with it for everybody, not just for mouse users. So with that, let's go back to our card flip. So the card flip demo it's where we instantiate this component. It could be reusable. You could have multiple team member components on a page, and they all have this card flip interaction. So I'm passing it some data. It instantiates this card flip component. Now, this card flip needs to manage some state. Is it active or not? We need to add some markup to this to actually be able to reach it. And it's sad how common I find user interface components that have completely forgotten the keyboard. So we're going to fix this right now. I'm going to go and check out the fixed state of this. I'm going to stash what I've got here. OK, so our card flip is in a slightly better state. So I'm going to give you a little tour of what I fixed here. Our card flip component, if we scroll down and look at this markup, now instead of just a series of divs that we hover on, we actually have a button. The button is focusable by default. The text inside of it is the team member's name and the little subtitle. It's a pretty short amount of content, so it's OK for a button name. I'm using the click event on a button, which works for everybody. You can use it with the mouse. You can use it from the keyboard. So this is way more accessible. So that button is then going to trigger the card flip, and that is going to expose the backside of this card content inside of a dialog element. I'm using a roll of dialog. It's similar to our landmarks earlier. If you're using the actual dialog element, you still need to bolt on this roll of dialog to expose its semantics in older browsers. So this is a good start. What we need to look at now is how we're actually going to handle this interaction. So when I land on that button, I'm going to fire that click event, and it's in React style. I'm going to change the state, and that's how I'm going to flip between the front and the back. Now, there's something you should know about this type of interaction is that we need to handle the user's focus, so they're not getting left behind in the background layer. So when it opens, we're going to send focus into it, and in React, a really great tool for that is the ref. The ref API, they've just added an even better handle for it with react.createRef. So for each element that you're going to send focus to, you can create a ref. It gives you a handle or a hook to add focus management. So we have one for the toggle, which is where it starts. And then we have a close button now. Because we've made this open on click, we need a way to get back. So let's go check this out in the browser. Now when I hover over it, that's the old version. So now it's not a hover interaction anymore. I've indicated that it's interactive by changing the text to have some other indication, which in this case is an underline. So when we look at it, we can tell it's more interactive than just text on the screen. So when I click on it now, I can actually fire this interaction, and my focus is sent into it. And so if I'm actually using the keyboard, instead of skipping right past this component, I can now land on it, I can hit the Enter key, and my focus is sent into this component. This is a pretty simple little card flip, but these keyboard mechanics you can use for other things, like modal dialogues, menus, which we'll look at in a second. But we want to make sure we're not just leaving the keyboard user behind completely, both by not making things focusable and then not handling their focus. So in JavaScript-heavy applications, we want to make sure we're mindful of managing the user's focus and sending them in and out of interactive layers. So this is a lot better. There's a little Twitter link in here that also needs a little bit of help. And one thing I want to fix now is if you're seeing this blue focus ring, you might be going, wait a minute, I need to turn that off. I hate that blue outline. I've been there. So I have a solution for you. Let's go back to our text editor. I'm actually going to add a tool called whatInput. All I have to do is include whatInput. I could download it from NPM. That gives you a hook in your CSS to actually style based on the user's input modality, we call it. So if they're using a mouse, you can style one way. If they're using the keyboard, you can style another way, and so on with touch. So whatInput, we just include it in our JavaScript. There's a similar standards-based solution coming called Focus Visible. That'll be a CSS4 selector. It's not quite ready for prime time yet, so I am still a whatInput fan. But we need one more piece to this. And I'm actually going to cheat a little bit and check out the solution. So if we add whatInput, then when we go to our CSS, instead of hiding the outline for everyone, which if you have outline none for everything, go nuke it from orbit, get rid of it. Use a tool like whatInput or Focus Visible to be more selective about how you apply focus. So with this data-whatIntent attribute that whatInput is applying to our HTML, whenever that matches, then we can hide the outline. And I'll show you what effect that has. Now when we click on this component with the mouse, we don't get that outline. So it keeps mouse users happy. But if I use the keyboard as an input modality, I still get that visible outline. So I can see where I am on the screen. Super important if you can't use a mouse or a trackpad even. Users that rely on that can't just magically grow the ability to see where they are on the screen. So this is super helpful, and it makes it easier to support all users. So that's a card flip animation, how we can support everybody by doing it. I guess before we move on, I want to show you what the tests look like for this card flip. So I've written some unit tests for this. It's debatable whether you want your tests to live in unit tests or integration tests. I think you can do both. It depends on what exactly you're testing. But for focus management, unit tests make a lot of sense if you're testing APIs. Like if you have a focus manager throughout your whole application, you can test with unit tests for that. In this case, I could have done either. I'm testing where the focus is being handled. I'm testing the state of this component. So I'm using jest for this component. I'm first testing the active state and checking whether it's, or I'm actually setting the state in the test to true. This is sort of the mouse user case and just using pure state. So the side effect of changing the state of this component is that it adds a CSS class of active. I can go and check if I modify the state if it is handling that appropriately. For the keyboard mechanics, I want to do that same thing. I want to see that side effect of the DOM being manipulated, but I'm going to simulate it using a keydown event. So with Jest and Enzyme in React land, you can simulate events. The catch with this is that your event handling has to be in React. You can't use Enzyme to simulate a native JavaScript event. So a little bit of a gotcha there. But since I did use React for this, I can go and simulate that event and check that my logic in my component is doing what I expect. So in this case, I'm simulating a key down with an enter key directly on that button that I created. And then I expect that it will also add that active class. So gotcha number 2 for focus management testing is that sometimes your DOM might not be ready when you go to test it. The test executes so fast, the element might not be visible yet, and you need to wait a tick. It sucks. I wish we didn't have to do that. But if you're actually testing for accessibility, you might have to become friends with the set timeout function. So set timeout, we just tell the event loop to wait a tick, and then our element with the focusable thing is actually visible and ready. And then to take this one step further, I've got the same API that we used earlier in the Axe WebDriver JS utility. I'm using the underlying JavaScript Axe core library. If you've ever used Lighthouse in Google Chrome, it is the same accessibility API used there. So Axe core, it is my favorite tool, but there are a few others. And the idea is that it is the same API to get some accessibility basics into your test automation. That way, if a teammate breaks something for accessibility, or you come back a few weeks later and break your own thing, you can prevent those problems from making it to production. So because I'm using Jest here, which uses JS DOM, I've disabled 2 rules in Axe. I've disabled color contrast and link in text block because JS DOM does not have some of the necessary APIs for that. But then you'd want to go back either in a browser extension or an integration test and run those color contrast tests again, because color contrast is actually the #1 accessibility problem on the web. In this case, my app didn't really have any color contrast problems, but we want to test for anything else that it might find. So I'm instantiating my component, I'm passing it some dummy data, and then I'm using axe.run to return that violations array to me, and then I can make similar assertions as I did in my integration test. So that's pretty cool. Let's run that. So I'm going to do npm test. That's going to fire up Jest. I can hit all, and we'll see what's going on. So our tests are passing, which is amazing. I've got that card flip. It's checking the keyboard mechanics. So if I broke it, like maybe somebody didn't know what the button was for, and they change it back to a div, that test would then fail. And it's not just accessibility testing off to the side. It's baked into our tests, so it's a holistic approach, and it really makes it embedded and mainstream. So I love that way of working, especially with test-driven development, when you can write a failing test, go add the feature, and then make the test pass. So that's a card flip. Let's look at our last component, which is a desktop-style menu. Now, if you're building something like a text editor built with web technologies, or maybe you actually have a complex web application that your menu doesn't necessarily navigate the user to places, but you can do things like find something or split content into lines. This menu that I have here is it looks like something you would find in a text editor. And when I hover over each of these selections, it opens that little submenu. So if I go and inspect this, let's go see what's going on with this markup. So the menu is an unordered list. It has a set of list items that are not interactive. So there's some hover going on here, but there's no handle for a keyboard user to get to. And the subcontent is just a sibling unordered list. There's no programmatic association between these two. There's no hooks for keyboards. There's no screen reader support. I just found this component on the internet. So when you're out there looking for components, you might find stuff like this. And without a second thought, all of a sudden you're shipping something that you thought was saving you time, but opens you up for some accessibility risk and leaving your users behind. So I thought this had potential. And so let's go look at how I actually fixed this. Let's go back to our text editor. I'm going to open up our menu component. It is using this React menu aim component. It's actually creating a React mixin under the hood. And then the demo that I pulled in gave me the opportunity to make changes to it. So the default state of this is just this unordered list, all this good stuff that is sadly not accessible. So let's go fix it. I'm going to get out of Jest. And I'm going to check out the fixed solution for this. And we'll go and make sure that our solution is showing. So I guess the first thing that I had to do was add something focusable. I added a few different items to this, including a roll of menu to indicate to assistive technology that this is, in fact, a desktop-style menu. And then inside of the top-level list items, I opted to create a button for each item so that it would be focusable by default. I'm giving that a role of menu item, so kind of overloading the default semantics of that element, but I'm getting the focusability for free. And this pattern is not something I made up. It's actually from the ARIA Authoring Practices Guide, which I'll have a link for in a minute. But I'm using their recommended attributes of ARIA has pop-up of true. I'm using ARIA expanded. Depending on the state of it, I can change that attribute to be true or false. And then this is where the magic happens, the on key down function. It also uses a ref, so I can handle focus management between here. To finish out our tour, I have the child list. Instead of being siblings, I moved it so that it's now inside of that list item. That way, we don't have to use something like ARIA controls, which, if you've read from Hayden Pickering, ARIA controls is poop. So we're really not supported that well. So I opted to use HTML's own hierarchy to make that association. And then the child items, for this stage 1, I just did the top level. When I handle the key events, I can hit handle up, handle down, and those will check where we are in the menu and change the state accordingly. So the state is really just setting the state of what the active index is, and then if I've used the keyboard, which I know because I've used the keyboard to get there, I can send focus to that item. So if I go to this menu now, it looks slightly different, but you can always play around with the style. But the idea of this desktop-style menu, it's not a list of links, it's actual menu for an application, is it acts as one tab stop. And I can arrow around, and now I can actually reach everything for this stage 1. So for stage 2, let's go check that out real quick. Make sure we don't have any changes. So for stage 2, it got a little more complex because now I have to manage the state of 2 levels. And so for my first pass at this, I had to add hooks for the number of items in both levels. I need to refresh this. I have to maintain the sub-menu items and all kinds of stuff. So you can check this out on GitHub to see the full solution. If we go look at it in the browser, now I can go through these top-level items, and I can get to the lower level of items. So with a little bit of refactoring, I was able to make this way more accessible than it was before. This is something I'll probably contribute back to the component, because when you're using components, you can really help other people out by filing issues for accessibility, and if you have the solution, contribute it or suggest it in the issue. So we've managed to make some things way more accessible than they were before. I didn't have any slides, so if you want to review what we worked on today, you can check out my GitHub. I've tagged all of the fixes in Git tags, and there's some resources here. If you're new to accessibility, if you need help, get your team members on board, I've got some resources here. The one I really want to point out is the ARIA Authoring Practices Guide. You don't need to reinvent the wheel with a lot of these interactions and components, so you can go check what's out there already, and you can go learn more about accessibility. My last caveat is that automated testing and this type of work will only get to the low-hanging fruit. So you also want to test with real users, because automated tooling can't catch everything. It can't make your app accessible. It relies on you to know how to make the components in your app more accessible with tips like I have in this repo, but then also test with real people. People with disabilities. See how they use your application. You might be surprised that they stumble and they've hit barriers. So I hope that I've given you some tools and techniques you can use to make your apps more accessible. Thanks so much for having me.